So if you're just joining the video now, don't worry about this. It's just not even a tangent. This is a full-on separate thing. I don't know where this comes from. I get distracted by things. Today we want to talk about arc length. It seems like a departure, but it is exactly related to radians. It's kind of one of the reasons that we have radians. And it's one of the reasons that I say y'all already knew about radians. And you all already know about arc length. Let's suppose we have a circle. Let's suppose we have a circle. And that circle has some radius, r. And here's where I find out if you know arc length already. What is the circumference of that circle? What's the formula for the circumference of the circle? 2 pi r. I knew it. Y'all already know about arc length. So, just as a reminder, remember the circumference of the circle is 2 pi r. That's the formula. That's how we figure out how long that is. It's the distance all the way around the circle. The circumference of the circle is the distance all the way around. The circumference of the circle is the distance all the way around the circle. This is where we get pi from. And whoever invented pi said pi is going to be the number that's the ratio of the circumference to the diameter. They did that while we were out at lunch. I'm like, oh, so it's going to be radius, right? And they're like, oh no, diameter. Son of a, we should use radius. Have you not looked into the future? It's like, oh, I like the diameter. And he's the guy that bought lunch, so we had to go with it. Really messed everything up. So the circumference of a circle is 2 pi r. We all remember that. We know that the circumference is the distance all the way around the circle. So what happens if I want the distance of just a semicircle? How much is that? That's still a radius r, but I only go halfway. This is still r. How far is this? What's this length? If it's half of a circle. We just, instead of 2 pi r, it would be half of 2 pi r. What's half of 2 pi r? Pi r. Oops, fancy r. What if instead of a half of a circle, I have a quarter circle? Pi over 2r. Oops. I dropped off the bottom. So let's take this half circle and cut that in half. So 1/8 of a circle. I'm running out of colors. So if I have 1/8 of a circle, it's going to be 1/8 of 2 pi r. And what fraction is that going to give us? Pi over 4. At this point, I have to stop drawing because I can't draw anything. So notice that we have a full circle, 2 pi times r. Half a circle, pi times r. Quarter circle, pi over 2 times r. Eighth of a circle, pi over 4 times r. Full circle, 2 pi. Half circle, pi. Quarter circle, pi over 2. Eighth of a circle, pi over 4. What are all those numbers? This 90-degree angle, how much is that in radians? This 180-degree angle, how much is that in radians? This eighth of a circle, how many degrees is that? 45, which is how many radians? See, we already knew our formula for the arc length because we use it every time we talk about the formula for the circumference of a circle. With the full circle, right before I was going to do 2 pi. I think that one must have separate. No, power just went out. Yeah, there we go. Oh, I gotta turn the thing. Okay. I'm pretty adept at filling my own momentum anyways. Yeah, because laptop is kept running on a battery. It just there wasn't enough light in my poor little camera's like, well, what do you want me to do with all this? So I know you can't see at home, but or I know, oh no, you can see at home, you can't see here. So the important thing to note is that when we say the circumference of the circle is 2 pi times r, I don't know if I'm going to get my projector back. When we say that the circumference of the circle, there we go. When we say that the circumference of the circle is 2 pi times r, 2 pi is the angle, and we just multiply the angle by the radius. And we just have to make sure that the angle is being measured in radians. So it's 2 pi radians times the radius r. For our semicircle, we take our angle in pi and multiply by r, the radius. We just take the angle and multiply by the radius. So if I have some rando arc, if I cut an angle of theta out of a circle of radius r, my arc length would just be theta in radians times r. I can't remember what this book uses. I think this book does use S for arc length. I think it's because they use capital A for so many other things and lowercase a. And L is not a good choice because a lowercase L looks like a 1. And uppercase L is used for a bunch of other stuff. So they went with S. It's like slope. But what letter would you use to represent slope? M, because of course, right? What else would you use? Here is the slope. M. There's got to be another language where slope, the word for slope begins with M, and that's why it's M. But as an American, I only speak one language, so we're never going to find out. So the arc length is the angle in radians multiplied by the radius. It's the same thing that we do for the circumference. But for the circumference, the angle is always all the way around. So that's why it's 2 pi. That's the angle in radians going all the way around. Right. And so when we have on a unit circle, our arc length, how much of the circle is there, is just going to be the radians. This is why radians are the way they are. This is why radians are the way they are. So on a unit circle, radius 1, arc length 1. This angle is 1 radian. Any questions? How's everybody doing? We look so sad. Were you expecting some bigger mystery about arc length and radius? Some deeper meaning, and then it's just this. It's like you get all the way to the end of the matrix and you're like, oh, that's it. One of the cool problem sets that you have when we talk about radians plays with this idea of arc length. And it's one of this arc length is one of the reasons that we need radians. So if we think about, and I don't want to do the whole problem, I want you to think about it. So I want you to imagine the spinning record. This record is spinning right round, like a record, right round, round, round. So the angle, everything on the record is going around at the same rate. It has the same angular velocity. So 45 revolutions per minute. So in 1 minute, this record will go around 45 times. Some record. There's also 33 and there's also like 78. But not all the points are moving at the same linear velocity. So if you've been in marching band, you know that when you're in marching band, if you're standing at the middle, near the middle, then you just kind of have to pivot. If you're in the middle, you just get to pivot like this. But if you're on the outside of marching band, as you're trying to go around, you freaking have to run. And so you're out there, and even though the person in the middle is like, oh, just spinning in place, the other person, even though you only have to go turn in the middle because your radius is 0, dude out here, radius of 5, has to go 5 times as fast because he's a radius 5. And so he has to run to get to the next point. This is why it's not a good idea on your car to have both the wheels on both sides just connected by one honking girder. Because when you make a turn, the inside wheel does not have to go as far as the outside wheel, and it messes things up. All the Mustang owners are going to come at me. Oh no, this is why it's better. Until they actually went to an independent rear suspension. It's like, no, this is better. It's fine. It's fine. You know what I mean? Does anybody here drive a Mustang? Your suspension is crap if you did. I'm just kidding. God, don't let me. But that's what's going on. This is why it's not a good idea to just build one axle with both wheels on it, because when you try to go around a curve, the outside wheel has to go farther. It has to spin more times than the inside wheel. So that's one of the things that we want to play with. And it's all based on an idea that you already know. Because if you know that you all knew the circumference of a circle was 2 pi times the radius. If you want a smaller piece of the circle, if you want a different angle, you just take that angle in radians and multiply by the radius of the circle. Any questions? Comments? Deep thoughts? That is not enough information to actually go do the homework based on everything that I said. You're going to have to think about it. But that is one of my favorite strategies. Tell people not enough information to do the work, then go make them do the work anyway. At a certain point, you got to get used to the idea of kind of making stuff up as you go and then checking to see if you are correct. The best thing I can offer is a nice, safe place to get stuff. All right, that's going to do it for today. I will see you all on Thursday. Everybody have a good couple of days, and thanks for playing.